Okay, so this is causal inference and statistics, that book right there. And we're on question 3.31, and there's 3 parts here, and they all center around this image right here, so we'll become acquainted with it as we go along. Okay, so part A is we are meant to list all sets of variables that satisfy the backdoor criterion to determine the causal effect of x right here on y over here. Okay. What this means is we have to find all of the non-causal paths between x and y and make sure that they're closed. And in order to close some of those paths, we will condition on that variable. But some of the paths are already blocked, and those are colliders. And if we condition on one of the colliders, we'll open one up. And so if we have to do that, then we have to compensate somewhere else. Okay. So here's the the forward path from x to y just goes x, w, y. So we certainly don't want to condition on w because that's part of the causal path. But now when we look at the backdoor paths or the non-causal paths, we have some leading out of x to a and out of x over here to z. All right. So one that we will have to condition on is z, because x, well, there's a backdoor path from x to z to y, so we have to condition on z no matter what. But notice that when we condition on z, z being a collider between b and c, we open up paths that might go b, c, d, y, or something. And so in addition to z, we would also need to condition on some of these other variables. So z as well as a or b, right? Because those will block the path that goes x, a, b, c, c, d, y, right? Or we can condition on c or d. So it's z and then one of these other variables around the outside. So, okay. Next is a very similar question. So now we need to list all minimal sets. Okay. So actually, let me go back before we make that distinguishment. So in part A here, we have to condition on z and then any of the other variables, a, b, c, or d, or some set of those. Okay. So we could condition on z and a and b, or z and a and b and c, or whatever. So, but now in part B, we're asked to look for the minimal set. Okay. So the minimal set. So let me come back up here to A. If I condition on z and a and b, notice that this is redundant. I've already closed a backdoor path from x, a, b, z, c, d, y, right? If I condition on a, and so by additionally conditioning on b, it's just redundant, okay? And so that would not be a minimal set of variables, all right? So in part B here, we want to find the minimal set of variables that will close all of these backdoor paths. So it's just z, and then just one of the following nodes, a, b, c, d. Okay. All right, and now for part C, we want to, now we're looking at different causal effects. We're looking at the causal effect of d on y, and then also w and d on y, okay, in 2 separate parts of the question here. And now we're trying to find, again, the minimal sets that will allow us to effectively estimate those causal effects. Okay, so just looking at the effect of d on y. So again, we're just looking to close all of these backdoor paths. So one way that we can close all of those backdoor paths very simply is just by conditioning on C. Once we condition on C, all of the other backdoor paths between D and Y are closed down. So that would be one of the minimal sets. But perhaps we can't condition on C for some reason. Well, then we could condition on Z here. Okay, but if we condition on Z, notice that we're opening up all sorts of backdoor paths because Z itself is a collider. So in addition to Z, we would also have to condition on these other things that are feeding Z. Okay, so on this side of the graph here, and you can kind of look at the detailed explanation if you'd like. So there's 2 minimal sets here, C, and then Z and one of these other variables over here. Okay, so those are 2 minimal sets, or there's many minimal, there's a lot of minimal sets there, Z and B, Z and A, Z and X, so on, or just C all by itself. Okay, so those are our minimal sets there. Now, now, if we shift here to this context where we want to find the causal effects of both W and D on Y, okay, well now we have to condition on Z for the same reasons up here that we had to condition on Z, right? When we were trying to find the causal effect of X, okay. So now it's non-negotiable that we have to condition on Z, but once again we need to close down all the backdoor paths that are opened by condition on Z, which is a collider. Okay, and so it's Z and some of these other variables here, one of these other variables. So anyway, I think that is good for now.